Uh, Today we are going to start molecular orbital energy level diagram for oxygen molecule. We know that atomic number of oxygen is 8. Its electronic configuration is 1s2, 2s2 and 2p4. Another oxygen 8 also having same electronic configuration 1s2, 2s2 and 2p4. Oxygen molecule having formula O2. This oxygen molecule is formed by the combination of these two oxygen atoms. When these two oxygen atoms come together, then there is formation of O2 molecule. These oxygen molecule total contain 16 electrons. This oxygen molecule contain total 16 electron. This is the electronic configuration for oxygen atom 1s2, 2s2, 2p4. But this 1s2 is lower energy orbit. That's why it does not take part in chemical bond formation. 1s is lower energy orbit. That's why it does not take part in chemical bond formation. Only 2s and 2p atomic orbital of each oxygen atom combine, overlap, and then there is formation of oxygen molecule. Means total 8 atomic orbital of oxygen have combined form new 8 molecular orbital. Means 2 atomic from 2s, each 2s, that is 2 atomic orbital from 2s and 6 atomic orbitals from 2p. Means this total 8 atomic orbitals take part in chemical bond formation and to form total 8 molecular orbitals according to the LCAO principle, that is linear combination of atomic orbitals. Then uh, molecular orbital energy level diagram, molecular orbital energy level diagram for oxygen molecule can be drawn. Uh, this is for atomic orbital for this is atomic orbital of another 2s. These two 2s atomic orbital, these two 2s atomic orbital overlap, combine to form two new molecular orbital. One is sigma 2s, another is sigma star 2s. Then these 2s atomic orbital contain 2 electrons. Another 2s atomic orbital also contain 2 electrons. Out of these 4 electrons, first 2 electrons enter into the sigma 2s molecular orbital. We know that the capacity of sigma 2s atomic orbital having accumulate only 2 electrons, so remaining third and fourth electrons enter into the antibonding molecular orbital, that is sigma star 2s atomic orbitals. And these four electrons are filled according to the Hund's rule of maximum multiplicity and Pauli's exclusive principle. So this is the first molecular energy level diagram for 2s atomic orbitals. Then another molecular orbital energy level diagram for 2p. This is 2px, this is 2py, this is 2pz, and contain total 4 electrons. We know that p orbit of oxygen electron, that is 2p4. Uh, this another 2px, 2p1, 2pz, also electrons. Uh, 5 2pz. This is for 5 star 2py and 5 star 2pz, and this is for sigma star 2px. This is the molecular orbital energy level diagram for oxygen molecule. It contains total here 8 electrons. Out of 8 electrons, first 2 electrons enter into the sigma 2px. Remaining 4 electrons enter into pi 2py and pi 2pz. This pi 2py and pi 2pz are called as degenerate orbit having equal energy. Then next two electrons enter into the first electron enter into the pi star 2py, and next electron, last 8 electron enter into the pi star 2pz. According to the Hund's rule of maximum multiplicity and according to the Pauli's exclusive principle. These total 8 electrons are filled according to the Hund's rule and Pauli's exclusive principle. So, oxygen molecular orbital energy level diagram of oxygen molecule indicate that there are 2 unpaired electrons present, and that's why oxygen molecule is paramagnetic in nature. Why oxygen molecule is paramagnetic in nature? Because molecular orbital energy level diagram of oxygen molecule contains 2 single electrons. That's why it is paramagnetic in nature. Paramagnetic in nature. Then electronic configuration of oxygen molecule. We know that 1s is lower energy orbit. It does not take part in chemical bond formation, and that's why for each 1s letter K is written here. Next electron enter into the sigma 2s. It contains 2 electrons. Next enter into the sigma star 2s. It also contains 2 electrons. Then next 2 electrons enter into the sigma 2px. It also contains 2 electrons. Next 2 electrons enter into the pi 2py and pi 2pz, also contain 2 electrons, means in total contain 4 electrons. These 2 orbits are degenerate. Then next remaining 2 electrons enter into the pi star 2py, contain single electron, and pi star 2pz also contains single electron. So this is the molecular orbital energy level diagram and electronic configuration. See the electronic configuration for oxygen molecule. K for 1s orbit, sigma 2s2, sigma star 2s2, sigma 2px2, pi 2py and pi 2pz each contain 2 electron, and then pi star 2py1 and pi star 2pz1. This is the electronic configuration for oxygen molecule. Then bond order of oxygen molecule can be calculated by using formula. We know that bond order can be calculated by using formula 1/2 number of electron in bonding molecular orbital minus number of electron in anti-bonding molecular orbitals. Bonding molecular orbital of oxygen molecule contain 6 electrons and anti-bonding molecular orbital contain only 2 electrons. Means 6 minus 2, 4. Which indicate that bond order of oxygen molecule is 2. Bond order of oxygen molecule is 2. These indicate that there is 2 bonds present in oxygen molecule. Oxygen double bond, oxygen. Bond order of oxygen molecule is 2. It is paramagnetic, bond order is 2, and electronic configuration of oxygen molecule. This is formed by the combination of 2 oxygen atom. Okay, this is about the molecular orbital energy level diagram, electronic configuration, and magnetism of oxygen molecule. Okay. Okay. Today we stop here.